Hey everyone, welcome to CE Chat hosted by Cloud OnAir, where we host live webinars every Tuesday. My name is Stephanie Wong, Cloud Customer Engineer, and today we're back again with Ryan Frisbel, Cloud Customer Engineer and Networking Specialist. So today we'll be talking about Networking 102. Last time we talked about Networking 101. Today's topic is Cloud Routing and VPC Peering. Just a quick note for everyone, there is a chance to ask live questions on the Cloud OnAir platform. We will have Googlers answering them live on the platform, but we'll also save some time at the end for any questions that you might have outstanding. So without further ado, Ryan, take it over.
Thanks, Stephanie. So as Stephanie said, last time we covered VPC, shared VPC, and interconnect. Today we're going to cover routing in the GCP environment and VPC peering. So when we talk about routing, there's a whole bunch of ways that routes get propagated within the Google Cloud Platform. There is what we call pre-programmed routes, there is dynamic routes, and there are what we call advanced routes. So I'm going to go through each of those. So pre-programmed routes are what we have when you set up a VPC and you create subnets. These are routes that get programmed in to allow VMs to talk to other VMs within the VPC. These are things that are automatically created, and these are also things that you cannot delete or change. So like I said, these are the routes that really allow a VM within the VPC to talk to other VMs within the VPC. There's also default routes that get created. So the standard default route that gets created is going to point to an internet gateway. And a common question that we get is, hey, I have this default route pointing to an internet gateway. Can my VMs talk to the internet? So the answer to that is no, not unless you put a public IP address on that VM. The difference between the default routes and the pre-programmed routes is default routes can actually be changed. So like I said, the default route that will be created in your cloud environment actually points to an internet gateway. But let's say, for example, you want the default route to point back to your on-prem environment. Unlike the pre-programmed routes for VM to VM communication, you can actually go in and change the default route. So a big part of understanding dynamic routing within the cloud environment is actually understanding the cloud router. So a cloud router is, in a lot of ways, very similar to a traditional router that you would have in your on-prem environment. But there are some fundamental differences, which I want to make sure you guys really understand. So in a typical data center environment, your router is going to be a big piece of sheet metal, has dual power supplies. It performs two real functions. It provides control plane functionality, which is really the BGP route communication mechanisms. And it also provides data plane functionality. That is, packets go into the cloud or into the router will look up its ribs and fibs and make routing decisions and forward appropriately. In the cloud environment, the cloud router is actually only a control plane device, right? So packets that go into your router on-prem, they actually don't go into the cloud router in the GCP environment. The cloud router functions as a control plane only device, and really it learns routes from your on-prem router or from other routers in the cloud environment. You can really think about it as a BGP speaker, right? It only speaks BGP, whereas your routers that you may have on-prem may speak other routing protocols. This only speaks BGP, so I want to make sure that we're clear on that front. What it does is it learns routes dynamically. It will configure routing tables. But then what it does is it actually pushes those routing tables down to the VMs themselves. So you can think of every VM in a cloud environment is really host routing, right? As opposed to, say, a host in your data center that when it needs to route a packet, it's going to push the packet to the router. The router is going to look at ribs and fibs and make a forwarding decision. In this case, the route table actually lives on the VM itself. So when the VM needs to communicate to something, be it another VM or maybe your router that is on-prem, it's actually going to route directly to that IP address because it has that routing table on the VM itself. One of the last things to understand about the cloud router is it is a Google managed process. So while you control it and configure it, it's actually a process that we run on Google hosts. And the big part to understand about this is if it fails, right, for any reason, Google will respin up that cloud router and reestablish the environment. There's nothing that you have to do in terms of your piece of that. As long as you've configured it correctly, in the event of failure, Google will take care of bringing it back up. So when you're setting up the cloud router, or when you're setting up your VPC, really, there's two routing modes that you can enable. So one is what we call regional routing, and the other is what we call global routing. So regional routing is where when you put a cloud router in a particular region, it will only learn subnets in that region. So for example, if I have an east, a central, and a west region, and I have regional routing modes enabled, the cloud router, if I put it in the west, will only learn the subnets that I put in the west region and will only advertise those subnets out to either a VPN that you've connected it to or a dedicated interconnect that you're connecting to, but it's only picking up those subnets that you configured in the West region.
I have a couple questions actually going back to that.
Sure.
The first question is, I know you talked about cloud routing being kind of the option for Google Cloud, but do we support any kind of other routers such as Cisco?
So we're working on that. The answer really is we will support other cloud or routers in the cloud environment, but I'm going to tell you why I don't necessarily think it's a good thing to do. So because our cloud router is heavily integrated with our platform, we're able to take the data plane off there, right? So if you were to go drop, a Cisco or a Juniper or other sort of cloud router in the environment, it's really creating a single point of failure, right? Because it's operating like a very traditional router. So you're creating a choke point because all the packets have to flow through that router because it operates very much like a traditional router in your on-prem, right? Packet flows to the router will look up, make a routing decision, forward things on. Now, what we're doing is we're working to figure out how do we integrate that more with the platform so that we can sort of eliminate that and make the functionality there more usable for customers and not have to create that choke point or single point of failure.
Yeah.
Because when that does fail, because it is a data plane device, your traffic dies with it, right? But as I talked about, when the cloud router fails, because it's only a control plane device, the data plane can still function as long as you have some other caveats, which I'll talk about in a little bit.
Okay, great. Thanks.
So let's talk about global routing. So we're talking about regional routing where the router only picks up regional subnets. The other option to configure in your VPC is global routing. And just to mention again, you set this at the VPC level, but this is actually how the cloud routers themselves will operate within that VPC. So global routing, really it allows the router to pick up all subnets. So back to my example, if you had an east, a central, and a west region, and you had subnets in all of them, remember when I said in the regional mode, if you put the cloud router in the west, it would only pick up the west subnet. But if you're in global mode in the cloud routers in the west, it'll actually pick up the subnets in the west, the central, and the east. So this really helps. It's very powerful in terms of when you're configuring VPCs, as we talked about in the first session, where you have a global VPC construct and you have a shared VPC construct, and you don't want to be putting cloud routers in all of the regions all around the world. You can actually put cloud routers in a couple regions, enable global routing, and have it learning routes throughout the entire VPC. So it simplifies your operational environment. Now, there are some caveats which I'll talk about when we get to load balancing, which is in a future session. Because load balancers tend to be regional resources, there are some very specific use cases where you'd want to use regional routing versus global routing, because there are such things as regional constructs in the GCP
I was about to follow up by asking kind of, I know you might not, we'll save it for the next one as well, but any kind of use cases for using one over the other, regional versus global?
Yeah, it really comes down to the case for load balancers, right? When you start to inject internal load balancers in the environment, then you have to be careful of using global routing. Because it's a regional construct, you could, in essence, create black holes where you're trying to route things from one region to the other, but because it's a regional construct only lives in one region, say you put the load balancer in the central and you're trying to push something from the west, it may actually not be able to reach it because it's a regional construct.
Okay, so this is something you kind of have to plan in advance.
Yeah, you have to sort of understand which components of GCP you're going to be using. That will sort of influence of like what sort of routing you want to use, whether it's regional or global. So.
Okay, great.
The other thing to talk about is route priority here. So for those that are familiar with BGP, route priority is the equivalent to the BGP metric MED, right? Just multi-exit discriminator. So when you see route priority in our console, just think of MED. That's how it will manifest itself when you go into your routers on-prem and you look at the route priorities. So the standard default route priority for all routes is 1,000. So if you don't change anything, when you go into your router and you look at the MED that your router is seeing, it will see all of your subnets you're advertising, and it will see a route priority of 1,000. Now, that will change if, depending on the configuration, where your interconnects are versus where your subnets are. So for example, let's go back to the east-west central sort of environment. If I have a subnet in the west and I'm advertising that subnet through an interconnect in the east, what will actually happen is the cloud router knows that that subnet lives in the west region, but that interconnect is in the east region. So it will artificially inflate that route priority by some value, which is based on the RTT time from where the interconnect was built to where the subnet is built. So for example, if you were advertising two subnets, one out of the east, one out of the west, to an interconnect in the east, and you set the route priority as 1,000 for both of them, and then went into your router and looked at the metric for MED, you would see that the subnet in the east had a route priority of 1,000, which is what you configured, but you'd see your subnet in the west maybe had a route priority of 1,700, right? And you're sort of asking, well, where's that other 1,700 or where's that other 700 coming from? It's coming from the intelligence that the Google platform has and knowing that that subnet is actually in the west. So for example, if I had an interconnect in the west as well and it was advertising those same routes, I would see the exact opposite. The route in the west, when you looked at your router, would have a med value of 1,000, and the route in the east would be 1,700. So you can use route priority, and where this really comes into play in terms of traffic engineering and how you want things to flow in the network. So a best practice is to always have multiple interconnects or multiple ways to connect in your cloud environment. So say you have an interconnect and a VPN. You could advertise all of your routes across the interconnect, and you could advertise all of your routes across the VPN. And the way that you would make the VPN less preferred from a routing standpoint is you would set the route priority higher, right?
Yeah.
So higher route priority or higher med is always least preferred, right? So for example, you could advertise the default 1,000 out of the interconnect, and then you could advertise all the same routes with, say, a 2,000 out of the VPN tunnel. And that way, when your router sees those two connections, it's always going to prefer the interconnect. But in the event that the interconnect fails, it's automatically going to fail over to the VPN.
Right. So there's still a way that Google would know how to reconciliate if you had something that had the same priority.
Correct. If you have something that has the same priority, like let's say you have two interconnects and they're both advertising the same priority, what'll typically happen is you're going to ECMP traffic across both of them. So basically, you're load balancing that traffic because it sees two routes with the same exact priority. There's no preference to one or the other. It's going to use both paths. So in this case, it could use an interconnect and a VPN or multiple interconnects.
Okay.
So
yeah.
So why is this stuff really important to grasp in terms of the cloud router? So I talked a little about failure impact, right? So when a cloud router fails, like I said, your data plane can still function, right? You just lost your control planes. The only thing is you can't update routes, okay? So, but you have to treat that a little bit differently in terms of your router that's on-prem. So what you need to enable is what we call graceful restart. So graceful restart, in essence, what it is your on-prem router, when it sees the cloud router fails and sees the BGP session drop, what it's not going to do is it's not going to start stripping routes out of the routing table, right? It's going to say, hey, I saw the cloud router fail, I saw my BGP session fail, but I'm just going to sort of play it cool, I'm not going to mess with any of the routing. And what's happening on the backside is, like I said, this is a Google managed service. So while Google is spinning up that cloud router, you're still pushing packets, right? Because again, it's a control plane only device on our side. So you can still push data plane packets, right? And what happens is after 60 seconds, the cloud router is going to come back up. It's going to reestablish BGP connectivity with your router on-prem, and then everything's going to be fine again. Now, the flip side is if you didn't have graceful restart enabled, as soon as the cloud router failed, you'd start tearing routes down, right? Even though that the data plane is still up and functioning, it would serve no purpose to really start tearing those routes down.
Right.
So that's a key piece to really understand the difference between, like I talked about, Cisco and Juniper, the typical routers that you have on-prem versus how a cloud router works.
Yeah. We're seeing a lot of value add here of the cloud routing versus kind of the traditional set, where that would be more of a single point of failure. Yeah,
and even with the cloud routers, we recommend running multiple cloud routers in the environment, right? Our typical practice is always run two, right? And if you're enabled with global routing, and let's say you have a VPC, let's go back to my east-west central sort of example, right? You could run one router in the west, one router in the east, have global routing enabled, it's learning all the routes. Maybe you have an interconnect in the east and west, you're advertising all routes across all interconnects. That way, if one cloud router does fail, you still have connectivity to the other cloud router. Now, again, we're going to reboot the cloud router that failed, but having two means you're always going to have that BGP connectivity and always going to be able to route.
So, of course, there's still best practices that people should be following, setting up multiple cloud routers, everything that you just talked about.
Yeah, typical best practices are use multiple cloud routers, use global routing unless you have some complex scenarios with ILBs or various other things, right? Those are two sort of best practices. And then on the on-prem side, like I talked about, set up graceful restart is definitely a best practice, so that when the cloud router fails, you don't start stripping the routes out.
Right.
The other thing to understand is, a cloud router, if you think about your routers that you have on-prem, right? It's a big box. It's designed with very small mean time between failure sort of scenarios, right? They're designed never to go down. So we're taking all that intelligence that you've put on a router and we're putting it on a very slim little Google managed host, right? So these are not these big robust chassis at your router. So it will fail at a higher rate than, say, an on-prem router. Now, that shouldn't scare anybody because I just talked about it. The router can actually fail. It does not disrupt traffic in any way, shape, or form, right? But you do have to understand that the construct is different. So that's why you have to sort of plan for these failures and engineer for them so that when they do happen, it doesn't disrupt the actual traffic flow.
Right.
So I talked a little about using multiple cloud routers for high availability. We talked a little about using route priority for traffic engineering. Again, this is where if you have multiple interconnects, you can be using the route priority to dictate flow. So if I want to choose interconnect A versus B, a common scenario customers may have is maybe I have some very critical infrastructure in the cloud. I'm going to build a VPN tunnel, but I'm only going to advertise that subnet over that tunnel, right? So maybe I'm advertising that subnet over the interconnect with a whole bunch of other subnets at a route priority of 1,000, and that's my normal path. But I'm going to advertise just that subnet because it's my critical subnet where I have a lot of critical infrastructure over a VPN tunnel. I'm going to do it with, say, a med of 2,000. So if I do fail, my core critical traffic will fail to the VPN.
Right, as a sort of a backup.
Yep. Now, you could advertise everything over that VPN too, but it just sort of depends how you're sort of engineering this. Okay, so let's talk about advanced routes. So advanced routes you can really think of as static routes. What you're really doing is you're configuring our SDN control plane and telling it how to route things, right? So a typical use case for this is really if you're trying to put, say, a NAT gateway in place, or say you're trying to run a third-party firewall and you want to force traffic to that. So a good scenario was, I talked about earlier, default routes. So maybe you don't want a default route to Google's internet gateway. Maybe you want the default route to point to a third-party firewall. You would use an advanced route to do that. You would basically say, I want for my default route within this VPC, the next hop to be the IP address of the third-party firewall that I'm using. So that's a very common use case, but you can sort of control that, and I'll take you through some examples of how that's actually used in practice. When you're actually configuring an advanced route, there's really a couple next hops that you can specify. One, you can specify an internet gateway. Two, a VM instance. Three, an IP address. Or four, a VPN tunnel.
Okay.
So I'll show you how to configure an advanced route when I
Great.
do a demo.
Perfect.
So let's talk about VPC peering. VPC peering is one way in which you can get two VPCs to talk together. The other way is VPN, which we talked about a little bit in the first session that we did. So the difference with VPC peering is it's binary, right? So whereas when we talk about VPN, you can advertise certain subnets. So if I have a VPN between VPC A and B, I could say I only want subnet A to be advertised across that, right? With VPC peering, it's binary. So all subnets in VPC A will get advertised to all subnets in VPC B. So if you recall, I talked about pre-programmed routes when we first started the conversation. Basically what you're doing is taking all those pre-programmed routes in A and you're programming them into B, and you're taking all the pre-programmed routes in B and program them into A. That's really what you're doing when you do VPC peering. Another way to think about it is you're sort of smashing two VPCs together to make one VPC. Now, the one fundamental difference is security policies, and we'll talk a bit more about security and firewalls in the next session. But the key thing to understand about VPC peering is the security policies are done at the VPC level. So even though you smash two VPCs together and make sort of one logical VPC in terms of the pre-configured routes, you still actually have two separate security policies. So I've had customers call me and say, hey, I've done VPC peering, I've put these two VPCs together, but I can't actually see traffic. Traffic won't route back and forth.
Yeah.
And typically it's because you have two separate security policies and the policies are written such that you're not allowing traffic from the other VPC.
Right.
So a lot of times, if you do VPC peering and things aren't working as you expect them to, go and check the firewall policies and the security policies that you applied in both VPCs.
This also makes me kind of think about, can you have overlapping IP ranges or subnet IP ranges? For
No.
those?
So when you peer two VPCs together, you cannot have overlapping IPs because it wouldn't know how to route them. It would say, hey, when it has to make a routing decision, it says, hey, I see this IP here and here, I don't know what to do.
Yeah.
So it'll actually, if you have two overlapping subnets and you try to peer two VPCs, it actually does that check on the backside and will tell you that you can't peer those two VPCs together.
Okay.
So if this is something that you're planning on using, you need to consider that, right, in terms of your IP allocations and your subnet setups.
So when you go to deploy, will it actually kind of prohibit you from deploying if it realizes that there's
Correct.
overlapping ranges?
So you'll build two VPCs separately, and then you'll say, I want to peer them. And you have to do peering on both sides, right?
Yeah.
So this could be used, for example, to interconnect a VPC that you own with a VPC maybe a customer organization owns, right? So what you don't want to do is you don't want to just be able to enable VPC peering to another VPC, right? It's sort of like a VPN configuration in terms of you got to configure the gateway on one side and the gateway on the other.
Yeah.
When you do VPC peering, you have to configure it on your side and you have to configure it on the other side, and both sides have to be set up to sort of match.
Right.
And then it'll allow the peering to happen.
Okay, got it.
So a few things to be cognizant about, right? There's quotas around this. So a common architecture might be a hub and spoke sort of architecture. So you have your hub and you have maybe 5 spokes. As long as the total number of VMs in that peering arrangement is not over 15,500, you're okay. If you go to exceed 15,500, it's not going to allow you to set up that peering session. The other thing to understand is you can have 25 peered networks, right? So if we have a hub and spoke environment, you can think of I've got one hub, I could have 24 spokes, as long as the total number of VMs are also under 15,500. So one last thing to understand there is the transitive nature, or non-transitive nature really, of peering. So what I really mean by that is if you have VPC A, VPC B, and VPC C, and A is paired with B, and B is paired with C, a lot of customers will ask, can A get to C? And the answer is no, because it's non-transitive in nature. So if you want A to get to C, you'd have to peer A and C, but A cannot transit B to get to C. So that's another key thing to sort of understand.
Okay. Is there do you kind of know the philosophy behind why Google wanted to design it that way?
It's really just to facilitate, interacting with other VPCs and being able to take all those pre-configured routes and being able to push them other places, really, right? Without having to use a VPN tunnel. Like if you just want to say, I want all the subnets here to talk to all the subnets here, but I've built them into two separate VPCs, it allows you to, in one way, like I said, merge them into one VPC, yet still maintain separate security policies
so
too.
For that use case especially,
Yeah. So you may have a security policy or a VPC that is, sensitive information that you want access, but you want to have a very specific security policy for it, right? Might be one example. Or like I said, if you're interfacing with a customer organization, so maybe you're a supplier and you have a vendor that you interact with, right? Well, you don't want to just have one VPC with one company or the other managing it, right? You want to have your own security policy and they want to have their own security policy.
Right.
Okay, so I'm going to take you through a reference architecture now. This sort of shows how all this works together. So what I've created here is 3 VPCs. So I have a standard VPC on the left, I have a shared VPC in the top middle, and then I have another shared VPC in the lower right. And then I've put subnets in there that you can see. So 10.1 is in the standard VPC, 10.0 is actually coming from an on-prem environment, 10.2 is on the shared VPC in the middle, and 10.3 is in the shared VPC down the lower right-hand corner. So now I want to interconnect a bunch of this stuff together, right? So the first thing I'm going to talk through is the standard VPC connecting it to the on-prem environment. So in this case, I'm putting 2 cloud routers in place, and I've built 2 interconnects. So you can see the dedicated interconnect in the east and the central region. So what those cloud routers are going to do is they're going to learn all the routes that I have programmed in the standard VPC, and they're going to advertise them via BGP to the on-prem environment. And that's going to allow the on-prem environment to talk to the standard VPC, okay? So that's the first thing I did. The second thing is I want to peer 2 of these. So if I take the shared VPC number 2, I'm going to peer that with standard VPC. So that allows, again, standard VPC and shared VPC to communicate together via that peering relationship, right? So what I have here is I have this, if you look at the bottom, it says programmed routes. So in standard VPC, I'm going to now have programmed routes. And again, these are routes that I talked about in the very first slide that you can't change, right? Because I set this peering relationship up, I'm going to have programmed routes for 10.3 in that standard VPC, right? And in the shared VPC, I'm going to have programmed routes for 10.1 subnets, right? The 10.1.1 and the 10.1.2 subnet, because those were the subnets I created in the standard VPC. And again, when you peer the 2 together, it's going to pre-program all those subnets into each of them. So that's what that programmed route section is. So the shared VPC number 1, in this case, the padlocks represent a third-party firewall device. So this is a scenario, maybe that's a finance shared VPC or something, when I want to limit connectivity to it. So what that device is doing is it's actually sitting with 1 NIC in standard VPC and 1 NIC in the shared VPC, okay? So in the standard VPC, I have the IP of 10.1.1.1. That's the NIC that's sitting in the standard VPC. And 10.2.1.1 is the NIC that's sitting in the shared VPC, okay? So now I want to be able to route traffic back and forth. So I talked about advanced routes. So let's take the shared VPC number 1. So in this case, I want to be able to route traffic from the shared VPC number 1 back to the standard VPC, okay? So in this case, I'm putting an advanced route in there for 10.0.1, which is really the subnet in the data center, right? So I'm saying all of that subnet, you're telling shared VPC it exists, but it exists somewhere else, okay? And the next hop to get to it is the firewall, right? So that's that 10.2.1.1. So what I'm telling it is for 10.0.1.0, that whole subnet, if you need to get there, which is the on-prem environment, go to 10.2.1.1, which is the NIC that sits in that VPC, okay? I'm also doing the same thing on the other side. In the standard VPC, I'm configuring another advanced route, And in this case, the cloud routers are picking up this advanced route and they're advertising it to the on-prem. So the on-prem knows I can get to 10.2 subnet, but when it comes into the standard VPC, it's going to say, oh, 10.2 doesn't live in the standard VPC. It lives in the shared VPC. And for me to get to 10.2, I need to go to a next hop of 10.1.1.1, right? So this gets a little complex, but it shows you how you can use VPC peering in terms of the shared VPC at the bottom, how you get pre-programmed routes and how they propagate, but also how you can like inject a third-party firewall in the mix and then configure advanced routes to force things through the firewall where you then implement your security policy.
So just to reiterate again, so GCP to GCP peering would be using pre-programmed routes to do peering for different subnets. Meanwhile, you would use advanced routes to force traffic to the next hop, which might exist in a firewall, third-party firewall.
It's usually a third-party device of some sort. So it could be a firewall, it could be a NAT gateway you've configured, but you want to force traffic to a particular device, right? So you're telling it. Another example might be, let's say that firewall is the firewall that I'm going to use to connect to the internet. So I could build a default route in shared VPC number 1 and say for all zeros, go to the interface 10.2.1.1. And that would push anything that's not part of your 10.private space to the firewall. The firewall would then do natting on it and be able to push it externally out to the internet.
Understood.
So that's just another sort of common use case for this.
Okay.
Like I said, this does get a little complex, so it's a little bit deeper of a topic to understand. But it just goes to show that when you're routing in cloud, there are lots of ways to do this.
Yeah. And if they're trying to map out kind of what they're doing on premise, then the possibilities are still here in the cloud. You can actually kind of map it out.
Exactly. There's lots of ways to do this. Like I said, you could use VPN tunnels versus VPN peering or versus VPC peering. Like we talked about, peering is going to be binary, so it's an all subnets to all subnets. Versus if you wanted one subnet to one subnet, you'd use like a VPN tunnel to connect them, right? So again, anything you can generally do in on-prem, you can find a way to do in the cloud environment. It's just you have to understand the complexities of routing and how it works and how the cloud router works and how routes get picked up and cascaded.
How they differ as well, Yep.
Okay, so I'm going to take you to a demo and sort of show you how this stuff works in the portal. So what I've configured here is I've configured a demo environment. Make it a little bigger so we can see it. So in this demo environment, I've created two VPCs, Cloud OnAir 102 and Cloud OnAir 102 Peering VPC. So I'm going to show you how the VPC peering routes sort of manifest. And then in the first VPC, I've created two subnets, one in US Central, one in US East, and that's 10.1 and 10.2. In the peering VPC, I've created a subnet 10.3. Okay. So that's our standard setup. Now I'm going to take you through the routes so you can actually see how these routes manifest. So when you're looking at this in the Google portal, you can understand what you're looking at. So I'm going to go over here, and I'm going to go down to routes. So this is the first page when you come into the routes piece of things. It's showing you all of the routes here. So you can see a number of these default routes. These are the routes I was telling you that are pre-programmed, right? So these first 1, 2, 3, 4, 5, we got 5 or 6 routes here that are default routes. You can't change these, right? And then it's showing you, we've got some peering routes in here. And then I actually have a cloud router created that is actually talking to a router I've configured off-site from this. And I've set that router to advertise some subnets down here. So the first page, it gives you the total view of all of your routes, which for this simple environment is very easy to look at, but I've seen customers that literally have 10 pages of this, so it becomes a little more complex to look at. So if you want to look at what you're learning from a dynamic perspective, so you can see these 192.168 blocks. When I clicked on the dynamic tab, this is what I'm learning from the cloud router. So again, I configured a router outside of the cloud environment, and I told it to advertise these routes. And I didn't put any med on there, right? So it's set with a med of 0 effectively, and that's why it's showing up as route priority of 0 on this side. And then the next hop IP address, this is actually the IP address of the off-site router that I configured, right? So as I said, when you look at a VM level, right, you're going to see these routes get programmed in there. There's 192.168 routes. And if they had to route, they would build an IP packet with the destination of 169.254.40.50, and they would route directly to that off-prem router that I've configured, okay? The other part is if you can click on peering, this is going to show you all of the routes you're learning via VPC peering. So again, you can look at all the routes in this first tab, but it's going to get very big and very complex if you're building any sort of real environment. So sometimes it's easier to look at, your default routes here, but again, you can't change those. And then if you want to look at the routes that you're learning, you click on the dynamic tab. And if you want to look at your peering routes, you click on the peering tab. Okay, so that's how your routes show up in here. So create route. This is basically the advanced route function I was talking about. So if I click on that, it's going to take me into the ability to create the route. So I'm going to give the route a name. I'm going to give it tell what network I want it to live in. I'm going to prescribe an IP range for it, set up a route priority just like I do for all normal routes. And then, as I was saying, you can basically point it to different things, right? So this is what I was saying, like if you're going to point it to a firewall, if you're going to point it to a VPN tunnel, or you would select what you want to point that route to, right? So that's how you configure it in here. And then you just click create, and it'll create that route. So in that VPC, that route will then live, and all the VMs will get programmed with that route. So like I said, it could be a default route, it could be a lot of different things.
Yeah. Can you do all of this in the Cloud Shell, or?
You can. I could do this in Cloud Shell, but you wouldn't want to sit here and watch me type everything out. Sometimes it's easier to do it in the console.
Yeah, absolutely.
So lastly, I want to show how easy it is to configure a cloud router, because they're very, very simple. People think of configuring a router, they think of I'm going to configure my Cisco or Juniper, which can be a very complex thing to do. In this case, it's actually very simple. So this is the cloud router I've actually stood up. As I said, I have a cloud router in this environment. I'm learning routes from another router that I've configured. So you can see I've got an up BGP session right here. But what I'm going to do is I'm going to create another router. So in this case, let's just give it a name. Just call it test 1. I have to drop it in a particular VPC. I have to drop it in a region, as I said. If you're using regional or global, this could be important. So I'm going to drop this in US Central 1. And then I have to tell it what ASN number is this representing. So the cloud router I configured in here before was 65001. So to be consistent, I'm going to put the same thing in here. I'm going to click create. And it's going to go and it's going to create me a cloud router. So this is the cloud. I mean, it's literally that simple to create the actual cloud router. Now I have to attach it to things, right? So I have to attach it to a VPN, or I have to attach it to an interconnect, or various other things. So that would be the next step here. And then once you have it attached, then you're going to bring BGP up, right? So then you can start advertising routes. So really there's 3 steps. There's creating a cloud router, attaching it to something, a tunnel or an interconnect, and then establishing a BGP connectivity, and then going back to the routes menu that I showed you and verifying that your routes are flowing.
Okay, so still you might have some configuration that you need to do back on your on-premise network.
Yeah, you're going to have to configure your on-prem router. So like if you set this up to, say, connect to a VPN tunnel, and that VPN tunnel terminates on-prem, you're going to have to configure your cloud router, you're going to configure your VPN gate, or you're going to configure your on-prem router and your VPN gateway and your on-prem environment, just like you would in the cloud environment. Once everything is configured on both sides, then you'll see the BGP session come up like I have here. This green check is what you're looking for.
Okay.
So that's it. That's pretty much a high-level overview of sort of routing in GCP and VPC peering. So let's go take some questions.
Yeah, we'll be back in just a minute for some questions. All right, thanks so much for all of your questions. Here we have a handful. I'll go ahead and read them out. The first one is the cloud router operating and or configurable at layer 2 or 3?
So the cloud router itself is a layer 3 device. It operates just like a traditional router, right? Depending on the interconnect type, so if you're using like a dedicated interconnect or a partner interconnect, that's really a layer 2 interconnect where you're going to configure the interconnect, and then what you're going to do is you're going to build a VLAN attachment. So that's your layer 2 element. And what you do is you attach the VLAN off of the interconnect to the cloud router, right? But the actual configuring in terms of the cloud router, it's actually operating only at a layer 3 level. It's really just an IP routing device.
Okay.
Like I said, it's really a BGP speaker.
Right.
That's really what it is.
Okay, great. So next question is, can you apply instance and route tags to route traffic to specific instances?
So you can. So there's a concept of tags where you can apply, so say I create a route and I want a route to only be applied to certain VMs, right? when you create the route, you could say, I only want this route to live on certain VMs, and you would do that by specifying a tag, right? So you could say, I want this route, so maybe it's a default route you don't want to live everywhere, right? Or some other specific route. You would build that route, and you would say, I want it to live on VMs that have the red tag. And then when you create VMs, you create the VM and you put the red tag on it, and then what will happen is it'll import that route into that particular VM. So you could have routes that live on some VMs and not others by using tags.
Okay, so you can map using tags. Next question is, how do you ensure you can maintain routing locality to keep the next hop in the same region or zone?
So routing locality, it's sort of a complex sort of piece of the puzzle, right? So this is like, where's your interconnect versus where your subnets? This gets into the topic of like, where do you put your ILBs and things like that, right? So it's really about understanding where you've provisioned things, and then setting up the routes to route appropriately to them, right? So for example, if I have an interconnect in the east, right, and I only want the subnets in my east region to flow through that interconnect, I probably wouldn't use global routing, right? I might just use regional routing and only advertise the subnets in the east to the interconnect in the east. And maybe I do the same thing in the west, right? I have a cloud router in the west with an interconnect in the west, and then I only want those routes to be advertised through that interconnect, right? So that way you're maintaining locality where the interconnect is in the same region where the subnets are, versus if you're using global routing, like I explained before, you could actually advertise your east subnets to the west, right? But they're going to have an inflated med, right? Because of the RTT distance that we're going to compute for you. So there are ways to do it. A lot of times, like I said, the biggest thing you have to be concerned about here is when you start to put ILBs in the mix, right? Because then global routing can really bite you. You want to make sure you understand the concept of locality. So like where that interconnect is coming in, the ILB has to be in the same region. If you have an interconnect in the west and an ILB in the central region, the interconnect lives in the west and the ILB lives in the central region, and they can't talk to each other, right? So if you have global routing and you're advertising a subnet out of the central through the interconnect in the west, it's actually going to come in the west, but it can't actually hit the ILB.
I see.
So that's where sort of this gets
so there's three
more
factors.
complex.
Load balancers, keeping it as a regional cloud router, and advertising the appropriate subnets.
Yeah, how you want to sort of advertise the subnets.
Yeah. Okay, great. Next question is, are firewall rules imported into a peered network?
So no. So when you do VPC peering, as I mentioned, the firewall rules and the policies are designed separately, right? So VPC A has its own set of security policies and rules. VPC has its own policies and rules, right? So if you, let's say, example, I have 10.1 in VPC A and 10.2 in VPC B, right? I may have firewall rules that allow 10.2 to talk to a whole bunch of stuff, right? And I may have firewall rules in VPC A that lock down 10.1, right? Those rules I've written do not go across with peering, right? So you still have to configure the security policies independently, right? And you have to enable that peering flow potentially. It depends what your policy really is. If you have your policy locked down really tight, you could peer two things and actually nothing could happen. If you have a very loose policy where you're sort of letting any VM to talk to any VM with a, say 10 dot address, then chances are you're not going to have any issues.
Okay, it depends if
But to answer the direct question, no. The rules that you write in policy A when you do peering do not go over to VPC B.
Okay, got it. And the last one is, can an instance have more than one network interface, within each interface in different VPC networks? Sorry, say that again,
Yeah, so this was a good example. This was the third-party firewall that I configured in that sort of use case, right? So that was an underlying VM running a third-party firewall appliance on top of it, and it had one NIC sitting in the VPC on the left and one NIC sitting in the VPC on the right. So you can absolutely do that. You actually have 8 NICs to play with.
Okay.
Now, one NIC can only sit in one VPC, right? So if I have a VM and there's 8 NICs on it, only one of those NICs can live in VPC A, one of those NICs can live in VPC B, and I can basically connect it to 8 different VPCs.
Okay. And that's at the instance level as well. Like one VM could have multiple networks.
Correct. One VM is going to have 8 effective NICs on it.
Yeah. Okay. Wow, that really expands the use case, I think, there.
Yep.
All right. So I think that's all the time we have. Thank you so much, everyone, for joining us today. Please stay tuned for the next session, which is how AppMaker can enhance the G Suite experience. Thank you so much, Ryan.
You're
We'll see
welcome.
you next time for Network 103.